Hey everybody, welcome back to ETS21. My name is Dylan Lockwood. I am senior editor at Z Prime. If you recognize me from other stuff, then hey, thanks for continuing to enjoy our content. And I hope you enjoy this panel on automating the grid of the future. And we're going to start. By introducing all of our lovely panelists with our friend Amanda.
Awesome. Hi, everyone. Amanda Freich. I currently am the Vice President of Sales for a company called Makatu, where we make optical sensors, which is the cool thing virtually hanging behind me. I spent my entire career in the energy industry, electrical engineer by education and by passion. And, I'm really excited to have this conversation. We got to have a couple pre-talks, and I think you guys are really going to enjoy it. So thanks for being here today.
And we thank you for being on too. We also have Rebecca on as well.
Hi, everyone. I'm Rebecca Foster. I'm the CEO of VEIC. VEIC is a clean energy company that operates utility scale efficiency and renewables programs in several states and has a national consultancy focused on bringing equitable and innovative decarbonization solutions to the people and places that need them most. I've worked in clean energy for over 20 years and am participating today from my home in Vermont.
Vermont is lovely this time of year, and actually most times of year.
Except February.
Yeah. Yes, well, except February. And then moving south down to Austin, we've got Cameron.
Hi, everybody. Cameron Freeburg. I'm a utility strategist at Austin Energy. I've been with the utility about 9 years now, and I work in a team called Electric Vehicles and Emerging Technologies, where we focus on basically bringing in DERs into our system. And unlike Vermont, Texas is not as beautiful during this time of the year. That's why we're all inside right now. But yeah, looking forward to the conversation today and talk about how we do DER integration.
Thank you, Cameron. And finally, we have Sasha.
Hi, everyone. Sasha Faltin. I'm a principal industry consultant from SAS. We are a statistical AI firm, and I've been in the industry for 21 years, working at utilities like Hydro-Quebec, Duke Energy, or at vendors to utilities like GE, Siemens. It is my passion. I've been doing it, like I said, right out of school, trained as well as an electrical engineer, and really happy to see the grid is transforming. It's things you were hearing when you were in school, and it's been taking effect and continues. And it's more complex, but it's also more interesting. So looking forward to the conversation.
Thank you very much. So yeah, we're here to talk about automation. We're here to talk about DERs and sort of this this DA ecosystem that's being built on the grid. So Cameron, I want to start with you, just at a good base level. What are some of the key logistical challenges of DER integration, and are there opportunities within those challenges for automation?
Yeah, absolutely, Dylan. And so, when we talk about DER integration, we're obviously covering a pretty broad spectrum of technologies here, and everything's kind of at a different level of how mature it is to go into like a utility system. So, I mean, one of the biggest lessons learned that we've gotten over the years is if you're going to start disrupting something, you want to understand what that is you're disrupting. And so, we're bringing new stuff to like a 100-year-old system. So there's quite a few areas for integration and understanding that make a lot of sense when bringing these in. So the first one that everyone always wants to look at is the kind of does it work piece. And so that's really around the area of like technology integration. And so figuring out bringing this in, will it connect logistically, like on your distribution system, as a utility, what kind of software components are in there? Do they talk to utility software components, and is all that compatible? And so a lot of the goal in doing this kind of integration is making sure you're not building, a bunch of different one-offs and a bunch of different management systems and a bunch of different things that kind of live on islands that you have to manage. So how does something integrate within your system is kind of one of those areas that everyone looks at first in terms of technology. But there's a lot of other areas too that fit within the way utility operates where DERs have to kind of be integrated. So one is around the customer opportunity side of things. And I'll kind of touch on this for a moment, but we're building out a distributed energy resource roadmap of integration right now, at Austin Energy. And so that's one of the 4 areas we're looking at in terms of there's the technology integration side of things, there's a customer opportunity side. So, if your customers are going to adopt this, how do you kind of create that handshake with that customer base and those technologies? How do you incentivize that kind of adoption? And how do you kind of make those beneficial to both the customer and the utility? So that there's that piece as well. And then also making sure that you don't have barriers in terms of policies or like the typical system planning you do. So things that we have, like the way that we interconnect technologies with our system, even some things that might seem like they're in place, but simple processes like permitting for new technology. And we're going through a lot of this stuff for like energy storage right now. As technology gets a little more robust, you go from phases of like research, and then you always typically go into something like where you're piloting it, and then you want to get to like full program or implementation of it. So making sure all those kind of necessities are in place, like, okay, well, what's a permitting process for energy storage look like in your territory? If it doesn't exist, it's very cumbersome to permit something that's never been done before, right? And making sure you have all the kind of safety protocols in place, making sure that everyone, even like your first responders that might have to, or your utility line workers that might respond to events for new DERs going in your system, making sure all those kind of traditional utility processes are in place, but now for these new technologies. One of the instances that I like to point to for that is when we were working on an energy storage rollout over the last 3 or 4 years, we partnered with some commercial customers in terms of putting battery storage at like commercial facilities. And some things that maybe not on the radar right away, but okay, well, what kind of ventilation do we have in these rooms where we're putting these battery systems? What kind of fire suppression systems do we have in these like boiler rooms where battery systems are going? In a lot of cases, it might be none. So you have to update and do all those kind of ancillary things that you might not have been planning initially when you're trying to launch those. And so that's a lot of that kind of back end stuff, just traditional ways that we integrate things and making sure they apply to new technologies. And then kind of finally, I think one of the biggest areas for utilities when, since we are an old industry and we have a kind of traditional way of doing things, a way we value things, of what our metrics are, but how do we kind of expand that toolbox? So there's a lot in terms of like, a lot of financial analysis for the way we produce and consume energy. That's pretty easy to figure out. But for some of these other areas, like looking at different business valuations for us, like what are some of our goals maybe around environmental stewardship, CO2 reduction, things like that. And so how do we look at DER integration now as kind of checking some of those boxes and measuring like integration of additional DERs to kind of go towards some of those goals as well. So there's 4 main areas that we look at in terms of DER integration and how we can seamlessly not make these things a one-off and make it kind of our core thought process. And yeah, it's, customers, the utility values, our policies, and then basically does it work in terms of a technology integration side of things. So very broad, but a lot of different areas.
Yeah, there are a lot of different areas. So Amanda, how has the convergence of technological advancements in purchasing power and operations at this moment in the utility, how is that changing the landscape of grid transformation?
We could go on for days about that, right? As we're seeing an industry that operated essentially the same way for 100 years get flipped on its head. Power always flew one way. We bought power a certain way. We sold power a certain way. And now we're looking at a situation where a lot of the great work that Rebecca's team is doing, and we're bringing these DERs to the masses, it really calls for a complete and total technological and cultural shift in how we do business. And it's needing new systems, new technology. Like, what we bring to the table at Makatu is we see ourselves as a very vital piece of the very much larger puzzle, right? And so it's looking at, okay, if I'm in a utility, which I used to be, Sasha and I have very similar histories of bouncing between, working at the utility and then helping on the vendor side, and saying, the people who are buying power and thinking about the flow of power from a financial and purchasing perspective, we didn't have lunch with the folks like me on the operations side who are more worried about the inebriated guy hitting the pole, right? And it was 2 different worlds of reliability of, do we have the power to buy and are the lights on? And now that's converging, and that convergence of thought is leading to a convergence in operations, which needs more systems and processes across the organization of our utilities that just wasn't there in the past. And so it's really fascinating to watch these different areas come together. And I think it's really fun to be on, not at the utility right now and getting to kind of play utility engineer everywhere we go and see how everyone's solving the problem differently. And so, from everything Cameron just said of all the challenges they're seeing, I'm sure, Sasha, you see it with your work at utilities too. Everybody has the same challenges, but different, right? And it's getting to solve those problems, as engineers, as different professionals amongst the organization, and look at how can we come together to create the responsible energy future that we need.
That's a good point. So like talking about solutions, Rebecca, what kinds of projects exemplify the direction that utilities need to take in this rapidly evolving ecosystem?
Yeah, thanks, Dylan. What I would start with is by just saying that there is a huge opportunity right now to meet customers' needs and improve their lives as we decarbonize the energy sector. But it is a really unprecedented and complex undertaking. And so what VEIC has seen is that for any distributed automation project, technical expertise is just one piece. We need that now across the utility, the buildings, the renewables, and the transportation sector, and that's just table stakes. And what really makes a project great is a strong understanding of community needs, relationships with stakeholders, and a willingness to really go deep with clients and partners to develop solutions that are going to work over the long term. So I would give a couple examples of the EIC projects that I think are rising to that bar. First is a solar-powered microgrid to power electric transit buses on Martha's Vineyard. And despite what you might think of when you hear Martha's Vineyard, transit buses on the island do provide a really critical service for thousands of low-income residents who live there year-round or who come onto the island to participate and work in the summer tourist industry. And VEIC worked with Vineyard Transit Authority, VTA. They wanted a more reliable, cleaner, and quieter bus fleet that could provide the service they needed without compromising on their reliability and their need to ferry people around the island. But switching fuels is complicated, and living on an island can mean unpredictable power, making electrification a complicated prospect for the transit authority. With careful infrastructure planning and a single customer microgrid under VTA's leadership, to transition the bus fleet to electric, ensuring that both demand and reliability concerns could be met through solar, through battery storage, and through en route induction charging. And so that collaboration really laid the framework for the nation's first integrated, clean, and resilient and flexible public transportation system. The fleet is 50% electric today, and once it meets its goal of being 100% electric, it will reduce carbon emissions by 36,000 tons over 10 years and forego 1.4 million miles of diesel travel annually. So big impact through that integrated kind of planning approach that I mentioned. And then the second example I would give is work to develop a resilient and affordable housing community on a Vermont brownfield. For this project, VEIC brought together a real coalition of engineering, utility, housing, and funding partners to develop an all-electric affordable housing community. It's comprised of multifamily and single-family homes and is located in a historic downtown in a brownfield, so urban infill, meaning that it's walkable to core services to reduce transportation energy use. The community features zero energy modular construction, as well as a DC microgrid, and each home is powered by shared distributed energy resources from adjacent solar. So, the locally generated and stored energy will allow the community, as well as some nearby residents, to maintain power for multiple days during an outage. While the project is still underway, the impact is huge. Not only does this provide affordable housing, which is sorely needed, but it also, minimizes the time that residents will be offline during outages, and reduces overall energy usage and environmental impact. So these examples to me are really good ones to demonstrate the power of taking a comprehensive view of our energy system. And they demonstrate what you can achieve if you have a relentless focus on working with partners to bring clean energy to those who have been left out so far. And that's what VEIC is trying to do.
Thank you for that. Sasha, talking a bit about some of the work you've done, how's the dynamic of grid inertia shifting with DERs, and how can companies address that?
Well, I like how you mentioned, and we heard it from Rebecca, Cameron, and Amanda that it's an evolving ecosystem with a variety of DERs. So we talked about transportation, we talked about battery storage, photovoltaic. All of those are changing the grid, and I like the expression of the electric grid is the most amazing machine humankind has ever created. Well, we created it in a certain way to work on fuel-powered turbines, and those fuel-powered turbines, we agreed, are going to turn to provide you 60 hertz, and that's how it keeps your lights nice and stable. Now we're putting in DERs, and those don't support that. So there are existing solutions to that. Utilities have spinning reserve where they're uneconomically spinning those turbines to support a change in the network. So let's say a load disappears, there's a weather event, takes down a major line, you got a load change, these turbines are there to pick it up. You also have expensive but helpful supporting equipment like FACT devices, which have been put into place in states like where I live in California, where there's quite a bit of DER penetration, and those are very helpful. However, they're expensive, and that only supports the network. It doesn't provide power. So it is an option, but it's an expensive option. Then you've got frequency regulation markets. Again, there's a cost associated to that, and FERC's done a good job putting in Order 755 to make sure that DERs are counted into that. But there's a big shift with that, and I would say that those options are there. They're, the worst option is obviously an emergency load shed where you're putting in the dark some of your customers. But with DERs, we talk a lot about hosting capacity, making sure that we have proper representation of different communities who have access to these technologies. And I would say what we've seen with some of our clients is making sure that there's a more accurate load forecasting. So we're talking about being able, Cameron talked about commercial battery storage systems. So that's at a commercial customer site. You want to be able to see all of that and forecast your load more precisely. One of our customers went from 92% accuracy in load forecasting, great number, but they got to 98%, and just that shift is a huge improvement to a utility that's expected to keep the lights on. Reliability is still the #1 factor for satisfaction of customers. If you check your JD Power and Associates customer survey, that's still the #1 factor. So I would say the importance of having a holistic view of your load forecasting of your IDP, your integrated distribution plan, having it more accurate, but what's going to be the most important is the frequency of it. So, it might take 3 days right now to do your load forecasting, but we've helped clients bring that down to an hour. And I would say that needs to continue to improve as we're really having to deal with DERs that turn off and on at unknown times most of the time. And at the same time, we have fewer of these spinning turbines to support frequency in the network.
Thank you, Sasha. So I'm gonna open things up here for just a sec, and whoever feels comfortable fielding this first, go right ahead. But are there any key lessons you'd like to share in DA processes that you've been a part of? We talked a little bit about what some of the challenges are, what the landscape looks like. So I'm just curious if you have any lessons to share with the stream.
I'll jump in, especially on distribution automation. I spent the first half of my career working directly for the utilities and doing a lot of what we used to call smart grid. Now we call it grid modernization, or 100 other classy terms. But I think it's really understanding from the utilities perspective that as much as it's a technological change, it's also a cultural change. And I remember putting in SCADA switches and having Troubleman look at me and saying, "You're going to kill us. How dare you operate something in the field without us physically doing it and knowing it's happening. And so, I apologize for some background noise here. But looking at how do we move forward with that technology, and make sure we bring all the stakeholders together and stop doing things in silos. Because I think we all can agree that the utility industry is very siloed. And when we come together, we're able to create really creative solutions to bring us all forward.
Yeah, I don't mind kind of going off of that too, Amanda, what you just said, and to Rebecca, the projects you mentioned earlier. I mean, one of the biggest takeaways that I've gotten over the last several years is the amount of partnerships and collaboration that are necessary in places that utilities haven't typically done that. I mean, I think a lot of the way that utilities interacted with customers over the years, previously has been like a one-way street, and so that interaction a lot of times has been either, okay, I'm either setting up service with an account, or I'm responding to an outage, or I'm doing utility planning for like new buildings. And so some of the work like Rebecca just mentioned in terms of like mass transit, electrification. And so we as a utility now are partnering with a lot of outside, agencies in terms of things like, advising and prepping for like bus electrification here in Austin, getting involved in now like guidance of like building codes and things like that that'll direct our future, because we know a lot of these DERs are coming in like the transportation sector. Potentially, if storage gets more and more inertia going up forward, how do you kind of prep for all this future integration? So there's a lot more work or partnerships with places that utilities might not have historically worked with all the time. And so getting that involved in like planning processes and stuff like that is very important, and starting early on, so you don't design something, technology comes, then you redesign it 5 years later, right? So
yeah, I'll add a little here. Now, to the point that we are, to both Cameron and Amanda's point, we are working with different stakeholders than we were before, and that can be difficult. Utilities are known for being siloed, but at the same time, I would say distribution automation, I've seen the positive of it. I've seen putting out devices, sensors, basically to have a better view of reliability on the grid, which was done for operation, comes into your SCADA. It's your operational team that sees it, but the reliability engineers, the reliability team benefits from that as well. So, and actually a lesson learned there that was applied to many projects is that everybody thinks their data is better than it is. I have definitely put out equipment and then gone to find it in the field, and the GIS data told me it was a certain point, and I spent time twirling around from pole to pole looking for it. So, putting the technology together, it is a big part. Cameron, you talked about that, and you got to prove that that works together, but also it might have been working for data for a certain use of it, and then as you're expanding that, you got to check it again because it might not work for your new use case.
Yeah, the only thing I would add, I agree with everything that's been said so far, is that I think a lesson learned, for many of the complex projects that VEIC undertakes is just the importance of technical advisors in a project to make sure that we're really vetting technology claims that vendors may come to us with. We often serve the role of an outside technical advisor, and in fact in Martha's Vineyard that was the role that we played in that project, really helping the transit authority understand what their options were, ideate what the new system was that they wanted to create, write RFPs for the solar procurement, for the buses themselves, for the control system, for the battery storage, look at how we could bring all that together. I think so much when you're working on the cutting edge and you're trying to push the envelope, so much is about experimentation, learning in real time, making fluid adjustments and changes as you go, that having an outside technical advisor can be a really instrumental part of getting a project like these done. So that's the only other point I would make. I double down and agree 100% with everything that's been said about breaking down silos and collaborating with other stakeholders to get this work to move forward.
Thank you all for all of those. And yeah, one of the things that I liked about what you were talking about, everything you were talking about was about how, how to run things, how to manage things. even though we're talking about, automation, we're talking about analytics, we're talking about all that, we've not I've noticed a lack of worries about technological barriers. I mean, that's the reason for that is because we're currently, flush with technology solutions. So, Amanda, what sort of what sort of structural changes need to occur for more seamless transitions?
Yeah, I think, the biggest thing I would say is, there's a couple of different kind of definitions of structural here. I think one is the structure of the organization itself, in the industry. I think there you really need to look at, we saw the emergence of these kind of smart grid teams or, the grid technology team, and everything sort of lived in these pilots, right? And to your point, Rebecca, of like, we gotta vet these different technologies. We gotta make sure they work. We have to make sure they make sense. We have to make sure they work with the existing technology that's already out there, right? Which I think is one of the biggest challenges, because you might have something that's brand spanking new out of a startup next to a piece of equipment that's been humming for 100 years, right? And so understanding that we need to make this business as usual, right? This is not, let's go pilot a bunch of cool things and they live over here without sort of that kind of political and regulatory backing that it needs to become realized. This is now how we do business. And we need to continue to do business like this to move forward. And then I think on, a structural look at just the technology itself is we have to be open to doing things a different way. And that has been a really interesting challenge in my current world where I'm dealing with optical sensing, because that's something that's not, very well known in the industry. It's not talked about a lot. There's other technologies that, people aren't super fond of or haven't been fond of. And so looking at, okay, here's a way that we can measure that we don't pass electrons, we're a lot safer, we can be more accurate. We have all these cool things, right? I'm not going to go into a sales pitch on it, but it's asking people to think differently and say, just because this isn't broken, right, doesn't mean we can't do it better. And that's something that I know I'm really passionate about. And I can tell just from the folks on the phone, I think we all are, is that we're really passionate about finding the right way forward for the industry, including the right technology, the right ideas, the right theoretical inputs, right? To make sure that our children and our children's children still have lights on in a responsible way with a planet that, is still relatively usable. So it's it's an exciting time to be in the industry. And I think there's so much opportunity, and the more we can create, an opportunity for really bright minds to come in and help us, the better off we're going to be.
Love the qualifier of relatively usable, but you're absolutely right in terms of making, trying to make the new ways of business the ways of business. So with that in mind, Sasha, with new ways of doing things, what are some of the new challenges cropping up in terms of implementation here, and where are some of the smartest investments to curb those challenges?
Yeah, good question. So I would say that we are putting a lot more equipment out in the field, right? Distribution automation means more devices in the field, and we have an expectation to make the best use of it for the longest time possible. So that puts a lot of stress on the asset management parts of utilities in terms of making sure that they know the health of that equipment out there. I would say, back to the point of structural changes, making sure it's folding back into the regulatory, into the new ways of business for the utility. I can think back to when I was at my first utility, and hosting anything on the cloud was just a no-no. That wasn't going to happen. Now it's sought after in multiple cases. Same thing with managed services. I've had clients ask me to manage their whole EV infrastructure, right? They basically want a turnkey solution. And for reliability, I think we have a partner who came in, Exactor, with a solution. I won't get into the technical part of it, but it's a sensor. And it was a very interesting concept. The sensor was not going to be owned by the utility. They're not asking for any upfront cost there. They would put it on top of any truck that would have a routine route. So theirs was sanitation trucks. So really interesting concept. You would have trucks out there that are already circulating. So therefore, you're not putting your field crews in extra hours of work, extra time on the road, extra miles, and therefore the extra danger of that drive. And at the same time, these routes are being driven already, and these sensors are picking up problems on the network with assets, basically any partial discharge for those of you who are interested in the technical part of it. And then they partnered with us because we do the data analytics part, which allows utilities to do a kind of reliability as a service. So instead of having to take care of all of that, having to buy the equipment, maintain the sensor equipment, now they're getting reports. And I think this is, again, back to the new structure of doing business. We're expanding our way of not just thinking about, well, it's got to be on-prem, it can't be cloud, or it's got to be, it's got to be our lineman checking everything. We can have devices out, and we can have interesting partnerships that benefit, third parties, and at the same time gives you that extra reliability without increasing risk to field crews.
Yeah, that makes a lot of sense. And so if we're finding new ways to do things, we're expanding capabilities here. I imagine there's gotta be some road bumps along the way, because uncharted waters and whatnot. So Rebecca, with all these with all these projects that you've been a part of, what are some of the common mistakes in DA planning you've seen, and how can planning be improved in general?
Yeah, absolutely. So I think the first mistake I would point to is thinking too small and focusing in on a single technology solution. To meet the decarbonization goals in front of us, we really need to think big. And I often think of the quote from Eisenhower: whenever I run into a problem I can't solve, I always make it bigger. We need to incorporate renewables, upgrade our homes and buildings to zero net energy, deploy millions of electric vehicles, and control it all with new automation technologies. And all of that needs to work seamlessly together and with the grid. So, I think all of us should take that premise to heart and really try and avoid thinking about just a single technology solution. No, there is no silver bullet. We need to be doing it all, and we need to be doing it all well. The second thing I would say is that utilities and clean energy companies, I think, make mistakes when they fail to truly understand the people that they're trying to serve, the needs that they have, what their day-to-day concerns are, and what they're trying to overcome in their lives. Our work on the DC microgrid in Vermont was really born from connecting with families and community leaders after severe storms, and understanding what going without power means for them in terms of receiving at-home medical care or trying to remote school their kids without power. Conference participants in Texas know this all too well from the storms of the winter. So, what I think I would leave the conference audience with today is that we will only succeed in transforming the energy sector when we truly understand the communities that we are trying to reach, when we go deep, when we show them how clean energy can make a difference in their lives, and then provide them with the tools that they need to adopt these solutions. That's the call to action. And I think that's what some programs fail to really recognize, because they're not connected in the way that they need to be with their constituents.
I think that's a great answer, and that's as you alluded to, that's not just the case with DA. It's not just the case with clean energy. Like, there's just that should be in everyone's mind throughout the whole conference. That's like, okay, when we're planning for the grid of the future, you gotta think big, and you gotta keep it focused on the communities and addressing their needs, because they are plentiful. Okay, so since we're talking about holistic planning, Cameron, from a utility perspective, how do you maximize benefits to historically disadvantaged communities within your service territory, as well as ensuring equity and reliability? Because I know that's a whole other panel, but I just was hoping you could touch on it now, since we're talking about being community minded.
Oh, it absolutely is. I mean, that's one. I mean, this is one that could be another hour-long conversation. But Rebecca hit the nail on the head there in terms of like just the understanding of your customers' wants and needs. Like even that level is first and foremost is just understanding. Okay, well, how do I enable this kind of either customer adoption or the benefits that customers might receive from, from these new areas, whether it be like our transportation system, like, actual new technology in our like distribution grid. One of the efforts that we did recently as a city of Austin is we actually kind of holistically did a climate equity plan, not just Austin Energy, but as part of the city of Austin. So how do we address things like our built community in terms of buildings, our transportation system? That's everything from like the bus down to the sidewalk, and it was all carbon driven. So I think one of the unique areas, and we're talking specifically about DERs here in equity, is so since this is also new and it's kind of transforming like an existing system, is we actually have the opportunity to build this equity, and as opposed to like go back and repair, or it's not just now addressing like some of the inequities that came in place from former systems that got built, whether it be lack of like sidewalk access, things like that. This is new enough, so we need to understand those areas, those sectors that are historically underrepresented, and it's a lot of it's like complex solutions that might have previously been ignored. So making sure like multifamily residents have access to all the same programs that the rest of our community has. And so there's a lot of things that might get in the way of that, like how do we deal with like different kinds of billing, or it's not quite like a single family home. So it's complex answers to some of those solutions that they're not quite as straightforward. And really making sure that you can have all those customers either have access to, whether it be EV charging infrastructure, programs around like renewable energy subscriptions, the benefits of battery storage or distribution upgrades, and really building that out equitably, as opposed to just doing patchwork. So
thank you for that. I will say we're getting close on time, but we did have a question come in for you, Cameron, as a lightning round question. Can we hear real quick about what Austin Energy is considering in their emerging tech planning?
Yeah, so in our emerging tech planning, there's a lot of areas on it. So I mean, I can kind of go through it, technology, but that'll take me hours. But in terms of one of the big areas is really the transportation sector and how that's coming into the utility. So we have a program that's been focused on electrification of vehicles for the last several years now. But that's that is going to be the largest low growth areas in our territory, and internationally it's going to be one of the largest low growth areas. So how do we incorporate that entire sector is one of the areas around emerging tech that we're really focused on. And because it's kind of hard to predict what that impact's going to be, because there's a lot of customer adoption. How do you do load controls on it? How do you plan for that future in terms of like building codes and all that stuff, having customer programs around it? So that's a huge area that covers every part of the utility for the most part now, especially when we're talking like medium and heavy duty vehicles, like Rebecca was mentioning earlier, these new very large but controllable loads. And so I mean, obviously one of the opportunities for us is, yes, we're looking at a huge load growth, but unlike everything else in Texas, this one's not based on temperature. So there's just as much of an opportunity as there is a threat for those. So the way that we bring in vehicle electrification, and then of course, some of the hot areas like energy storage, we did a large, I won't even call it a program. A pilot. It is a program at this point where we integrated storage from the residential all the way to the grid scale level. And how do we kind of further automate that, further integrate it, and make it more seamless and start stacking value? So again, that's a question I can go on for a long time about, and happy to share my contact info wherever posted that question to catch up with.
Yeah, thanks very much. And just thank you for being on. And Amanda, Rebecca, Sasha, you've all been fantastic. You're all a lot smarter than I am when it comes to this stuff. So I appreciate the education here. Yeah, and with that, I will call an end to this panel. Make sure to stick around to enjoy a conversation upcoming about business agility with my friend Jason Scarlett.
Thank you for the opportunity.
Yeah,
Thank you.
Thank you, Dylan.
Bye now.